Hello guys, today I'm gonna talk about the four principles of the object-oriented programming: inheritance, abstraction, encapsulation, polymorphism. But before that, I just wanna make a short recap on what we were talking about. So in the first video, in the first tutorial, I was talking about object-oriented programming, and I told you that this is another way of thinking. It's a paradigm, as the people say. What is that? It's a pattern way of thinking. So instead of thinking about if, else, and other constructions, we're thinking the way the normal brain, the human brain, it's thinking with objects. This is the most important difference. So this is another approach to solve the problem. Okay, after that I told you about the six elements of the class. The first element is the declaration of the class. This is the line when the keyword class is together with the name of the class. Of course, it could be not only on one line, could be on two lines. This doesn't change the situation. So the keyword class followed by the name of the class, it's the declaration of the class. Of course, we can have access modifiers upfront and other modifiers, as we will see soon. Okay, the body of the class is the next element. The body of the class is between the opening curly bracket and the closing curly bracket. So this is the body of the class. After that, we were talking about the so-called fields. Those are variables which are declared in the body of the class. Could be primitive variables or reference variables. All these variables are called fields. Instance variables, some of them are instance variable, and others are class variables if they use the static keyword modifier, or member variables. This is another term which the people usually use. Okay, so this is the fields. We also we're talking about the so-called properties. The properties are not fields, they're not methods as well. In C# we use properties to conceptually differentiate the methods and the properties, because in Java, for example, we don't have such thing as properties, and we represent the properties with accessory methods, which is a pair of methods, getter and setter, which represent the property. Here in C# we don't use methods. We could, of course, if we like, alternatively, but there is a special syntax construction which allows us to represent the properties with so-called properties. As you can see, they're not methods, because if they were methods, we should put here round brackets. They're not properties as well, or they're not fields as well, because otherwise they should be declared like that. As you can see, they're somewhere in the middle between fields and methods. After that, we were talking about the so-called constructors. So the constructors are pseudo methods. They're pseudo methods because they don't return value. They have this is better. This is a better representation here. So they don't return value, and their name actually matches exactly the name of the class. So they have the name exactly the same as the name of the class. Human in this case. In this case, we have another constructor which is human. We were talking about the method overloading. Here we can see the constructor overloading. So two methods with different signatures. In this case, we say that the method human is overloaded. And finally, we're talking about the so-called methods. Those are functions which are declared and defined in the body of the class. Okay, those are the 6 elements of the class. So let's repeat again: declaration of the class, body of the class, fields, properties, constructor, and methods. Okay, After that, in the second lection, we were talking about the static elements of the class. Where can we use the keyword static? Actually, we can use static in front of the class. So we can do something like that. In this case, the instances cannot be instantiated. We cannot create objects from such class which is declared as static. The class actually turns to be only a container for static elements. We cannot use, of course, static up front of the body because it doesn't make any sense. So for the rest of the elements, we can add a static modifier up front of the elements. So in other words, we can use static modifier for the fields. In this case, the field becomes a field for the entire class. Even we cannot access it anymore through the instances of the class. We just have to type the name of the class, something like human in this case. Here, of course, is not a good place to write, so we can say human dot, and if the access modifier allows that, we can access, for example, read only this, only read. This is how we access the static, for example, field, if the access modifier, of course, allows us to access it. We can have a static properties as well. Here we were talking about that. We can have a static constructor. The static constructor is called in two different situations. The static constructor is called when we instantiate the first object of the class, or when we try actually to access a static element of the class. The non-static constructors are called only when we instantiate an object from the class. Also, you can see that up front of the static we cannot have access modifiers, and the static constructor doesn't accept any parameters. And finally, we can have static methods as well. They're part of the class. In other words, none of the instances can be used to access the static method. We again use the name of the class to access these static methods. They belong to the entire class. They don't belong to each one of the instances. They're common for all the instances. Okay, this is the recap. So now let's jump into the new topic. Let me first make sure that this program works actually, and after that we'll jump directly in the new topics. As I said, today I'm gonna talk about the field app human temp is never used. Yeah, I agree, it's never used. Okay, so as I said, I want to talk about the 4 principles of the object-oriented programming. This is inheritance, abstraction, encapsulation, polymorphism, and today I want to talk about inheritance. Okay, and I'm gonna use a use case directly. So what if I'm armed with all the knowledge which I mentioned in the recap about the objects, about the elements of the class, and the static elements of the class, and I say, for example, okay, right now in our virtual kingdom, in our virtual domain, I want to be able to create students, not only human, but students. Let's say in my virtual reality, they are students as well. I said that the class actually is a syntax construction which allows me to describe the status and the behavior of the objects which I want to have in my realm, in my kingdom, in my virtual world. So in other words, I have to define a class. Okay, let's do it. Solution Explorer. I'll click with the right mouse button and I'm gonna say add new class. Okay, I know these lections are not quite exciting because you don't build anything, but actually you arm yourself with the necessary tools which will allow you after that very easy to build whatever you like. Okay, so student, I'm gonna play, of course, a little bit dumb in the beginning just to show you a different way of thinking, but I hope you'll appreciate that. Probably this is the most important, just to follow the way of thinking. So, student. Okay, and I'm very happy because I know the elements of the class. Here I have a declaration of the class. Here I have a namespace, which is exactly the same like the namespace of my other classes. So I directly start to create fields which will hold the values of my properties. And we said that it's a good practice, actually, the fields, to make them private and allow the access to these fields through the accessory methods. In our case, we have something which is better. We have properties. Okay, so private name, a private string name. Okay, according to some authors, the students are also human beings. So let's say that in our virtual kingdom, the humans have name and age. So we also have to have fields and properties, name and age, as anybody else, as human beings. And after that, they have a faculty number, which is the only difference between the human, the ordinary human, and the students. So happily we will create private integer age as well, and after that private integer f number. Let's accept that the faculty number is an integer. Okay, let's make it simple. And now we start happily to create our properties, string name, and we can get the value of the name, and after that we can set the value of the name equals value. And here something strikes me. Actually, don't we have already this property somewhere defined? Didn't we type this already somewhere, these properties and the very same code? So I did copy and paste, and this immediately rings the bell that there is something wrong here. The first thing which strikes me in this situation is the fact that the student, in fact, has the very same properties like every ordinary human being in my realm. In fact, I don't even represent properly the relationship between the student and the human, because before you become a student you have to be a human. This is one point, and the second point is I don't follow the principle don't repeat yourself. So I'm repeating myself by defining again the very same properties. So two reasons I don't like this approach. First, I don't follow the principle don't repeat yourself, and the second, I don't represent properly the relationship between the student and the human. You can become a student, but before that you have to be a human being. Is there a syntaxis construction which will allow me to do that? Yes, there is such thing, and it's even a principle of the object-oriented programming. We say that in the object-oriented programming you have to be able to represent inheritance. How that's done in C#? Here it is. Here it is how it's done. Student, I will put a colon, and after that I will say human, and immediately I inherit all the properties and the behavior from the human. And just to show you that, I'm gonna create right now, I'm gonna create immediately here population. I'm gonna create a new object from the class student. We said that immediately when we define actually a class, it becomes a type as well. So I'm gonna call this guy student1. I'll call new student. As we know already, the compiler will add a constructor without parameters, and we'll see just in a second how everything works. Okay, so I can create already a student one, and the most important is that we inherit all the properties from a human: age, balance, name. We also inherit the behavior, introduce yourself. So with very little code, actually, we have so many properties, we have so many methods defined already. We inherit all this from human. Okay, that's very good. Let's do it properly. Let's define here a property which will allow us actually to set and get the faculty number. Let's create a constructor. Let's create a method which is specific only for the student. Let's see how all this works. Okay, so I will say public integer f number, and I'm gonna create the getters and the setters. Return, oh, not name, of course, f number, and after that I'll set f number equals value. Without this knowledge, actually, you also can program, but you will be much more effective if you have the knowledge which I'm just giving you right now. Okay, so this is the property which I just defined. Let me have one constructor which will allow me to set the name, the age, and the faculty number. It's a public. It's a pseudo method which doesn't return any value. It should have the same name as the name of the method of the class student, and we will get string name, integer age, and integer f number. And notice something very important. When we inherit a class, we have to give a chance to this to the constructors of this class to initialize the object which we are inheriting. Actually, when we inherit a class, this class is called base or superclass. This parent class is called superclass in Java. Here in C# they call it base class. We can call it, of course, parent class as well, but the right term in C# is base. So right now I said that we have to give a chance to the base class of the constructor. We have to give the chance of the constructor of the base class to initialize whatever needs to be initialized. In this case, the fields name and age. We can do it through the properties as well if we like, but this is another topic. So how actually we can access the constructors of the base class? With the keyword base, and we send the name and the age, and after that, only after initializing, actually calling the constructor, one of the constructors of the base class, after that we allow it to initialize our own properties or do whatever we need to do here to set up our object. In this case, we'll say this f number equals f number, and that's it. Okay, so now if you look at here, you'll see that we got one error because we just told the compiler, don't create a constructor without any parameters. I'm in charge, I know what I'm doing, I will do it myself. So let's define a constructor without any parameters, because I want to show you the difference between the keyword this and the base. So I'm gonna say public, again student. This time I'm not gonna accept any parameters, and I'm gonna say this. In this case, what I'm doing is I'm trying to call my working horse. I'm trying to call this constructor. In its turn, actually, it's gonna call the constructor of the base class, one of the constructors of the base class, and after that we'll finish the job. So when I call it, I will say student default This is the name of the human being which is gonna be created, and after that this human being will become a student because I'm gonna set up the faculty number. So in other words, we're gonna create a object from the class student which will have a name student default, will have 0 age and 0 as a faculty number, and after that I'm not gonna do anything. So in other words, if I call a constructor without any parameters, on its turn this constructor is gonna call the constructor with the 3 parameters and it's gonna send these arguments. Okay, the actual values which we sent to the parameters are called arguments. I wanna introduce this term as well. Okay, and let's teach our student to do something. I'm gonna say public void display f number, for example. Display now f number, and this guy is gonna show his faculty number. My f number is gonna represent the f number here, which is f number. I'm gonna take the value of the field f number. Okay, I hope everything is clear right now. Okay, so I just created one student, and I showed to you how to create constructors. I said that it's absolutely mandatory to call one of the constructors of the base class to allow the base class to initialize, allow the base class to properly set up. Okay, let's call this student, for example, what's the name? Kirsten, and let's say he's 25 years old, and also his faculty number is something like that, 2345. Okay, and we can happily create a student 1 right now, and as you can see, it has all the properties which it inherits from the human: age, balance, name, and also in addition it has the faculty number. It has the method introduce yourself, which comes from the inherited class, from the base class, and I have as well display faculty number. Okay, I'm gonna ask this guy to introduce himself as well. Introduce yourself. I'm gonna run the program just to make sure that everything works fine. Introduce yourself, and here we go. Kirsten. I'm 25 years old and my balance is 14, my nationality, blah 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 blah. Okay, so Kirsten actually introduces himself as a student, as a human. Notice that, not as a student. The extra information about the faculty number is missing right now, so we'll get here again just in a second. Before that, I wanna show you how we will create another class of objects which are athletes. Okay, just to strengthen our knowledge, I just want to repeat again the same procedure, but this time not for the student but for the athlete. Okay, so I'm gonna click with the right mouse button, say add on the project, and after that I'm gonna say class, and I'm gonna create athlete. Just wanna introduce something to you. Athlete. Okay, the very same story. We're gonna inherit human right now. We're gonna inherit human, and we will be able to create immediately one athlete. Athlete 1, new athlete. So what happens actually is this in athlete. The compiler automatically adds a constructor. We said that there is always constructor, even if we don't define one. The compiler adds a constructor without any parameters and with empty body, and on top of that the compiler actually calls by default a constructor without parameters from the base class. So in other words, something like that happens. Public athlete, but before that base. So this is how the constructor which is added by the compiler looks like. If I have to write it, I will do it this way. Public, so constructor without any parameters, which doesn't do anything, and it's calling the base class the base constructor, the constructor of the base class without any parameters. So this is what just happened, and as you can see, I can create athlete. This athlete, of course, has only the properties and the behavior inherited from the base class, which is the human. So it can introduce himself, it has a name, it has an age, it has a balance, because we said that athlete, we didn't say that, but we are going to say it right now. Before you become an athlete, actually you have to become a human being. And we said that in our virtual world, every human has a name and age. Okay, just to strengthen our knowledge, let's do the same what we did for the student. We'll say that the extra property which the athlete has is a sport which the athlete practices. So let's create one private field which will say it's a string, and this is a sport which our athlete is practicing. After that we'll say public string sport. We'll set the getters and the setters, return sport, and we'll say set sport equals value. As I said, this is only a theory, but without this theory actually we will be blind. And don't regret you spent time to learn these details about object-oriented programming, about C#, because I believe you will become a better programmer. Okay, let's continue after this. Pause. Public athlete, string name, integer age, string sport, and we have to call the base class. That's absolutely mandatory. I'm gonna call the constructor with the name and age. We have such constructor there, and after that I will take care of the sport, which is sport. Okay, and after that, of course, I can create a constructor without any parameters. Public athlete without any parameters. I'm gonna call again this. I'm gonna call my other constructor, so everything goes through this constructor right now, and I'm gonna say default athlete age 0, and the sport, for the sport I just gonna put sport. Okay, and I'm gonna use empty brackets, and after that name, here I have a name, I misspelled name here. Okay, so I just corrected that. Okay, let's give to the athlete a specific behavior. I'm gonna say public human athlete public void display sport, and I'm gonna say console right line my sport is, and he will report his sport. Okay, let me see, it doesn't contain a definition of student and blah blah. Let me see where the error is. Student 1, athlete, student 1, where the error is. Here. Okay, it's fine now. So after that I can create one athlete, which I'm gonna call Christian. I'm gonna say that the Christian is 26 years old, and by default, not by default, but his sport is football. Okay, and I'm gonna ask him, the athlete 1, to introduce himself. Athlete 1, introduce yourself. Okay, here I wanna show you something. A student actually has asked me, can we inherit a student? Yes, of course we can. We can inherit from a student, not from a human. So I could write here student. So in this case, our athlete, we of course don't have such constructor which accepts only name and age. I can add, for example, 2, 3, 4, 5, and in this case it's gonna stop complaining because there is a constructor in a student which accepts actually only 3 parameters. As you can see, we cannot directly call one of the constructors of the human class, but only from the class which is on the next level, age. So I can say 2, 3, 4, 5, and this way I can create actually athletes which are students. So in other words, I will accept that all the athletes in my virtual world first have to become students, which is not real and doesn't represent actually the real situation which I want to represent. So I'm gonna use again human, but what I wanted to show you that is that we can actually inherit another class which we have defined, and this class can inherit from another class, and this class can inherit from another class, and so on and so forth. So and also here I want to talk about so-called single inheritance. In C# and Java we can inherit only one class, not more than one class. But we can have multiple interfaces. We will talk about that in a next tutorial, in one of the next tutorials. So we have a single inheritance, class inheritance, and multiple interface implementation. So this class actually can implement many interfaces, but only one class, single inheritance. In other words, the situation looks like that. This is not a UML diagram, it's a popular diagram, if I can call it this way. So this is my class human right now. The class human has been inherited by, probably not like that, has been inherited by 2 classes right now. I just created one class which is called student, and I have created another class which is called athlete. So this is my athlete and this is my student. Of course, I told you that it's absolutely legal and possible for example, for athlete to inherit student, or vice versa, the student to inherit athlete, if in our virtual world which we want to build we want that. Okay, so this could be athlete. Okay, I hope you got the idea. Okay, so now we have in our world student and athlete. Now I'll set I'll set the next goal. But before that, I'm just tempted to show you something else. Let me look at my mind 42, the mind map, just to make sure that I didn't forget something. So single inheritance, I told you that there is a single inheritance in C#. We cannot inherit more than one class, but we can have multiple interface implementations. So if there are more, if we wanna replace somehow the multiple inheritance which exists in C#, for example, we can use many interfaces. We can implement many interfaces. This is what they introduced in C# and Java. They have introduced interfaces instead of multiple inheritance. So base class, superclass, I told you about these terms, and parent class probably. Base keyword we use to access methods or constructors from the class which we just inherited. As you can see, with the base we can access only the class which is on the next level, deep in the hierarchy. Public class, student, human. This is how actually we declare the inheritance with a column. With the keyword this, actually we can call one of the constructor in the current class, call another constructor during instantiation. Base method, this is the way we call actually a method from the base class if there is a so-called hiding of the methods, which we will see just in a second. Access modifiers. Okay, so let me set our next goal. Okay, so the student and athlete right now can introduce themselves, but they use the inherited method introduce yourself. And what I want is, I want when the student introduces himself actually to show the faculty number. I want when the athlete introduces himself to show his sport. So in other words, I want something specific when the student and the athlete introduce themselves. I want to teach the student to introduce himself. But at the same time, I want to keep using the very same method. I don't want to ask the users of my API, application programming interface, because these methods, these public methods, actually become a part of my API, application programming interface, which the users of my classes, of my objects are gonna use. I don't want them to remember too many methods. I just want them to remember that there is a method introduce yourself, and in the entire hierarchy they can use for each one of the objects the introduce yourself method. Okay, in other words, I just want to define again in the student the method introduce yourself. Is it possible? How we are going to do it? Okay, let's take a look at that. Okay, so I want actually when I call introduce yourself, the students to say I am a student. My F number is, and I want him to show his faculty number, F number. So right now my Kirsten, my student Kirsten, is going to introduce himself by saying I'm a student, my F number is, and to show his faculty number. Okay, let's start this and see if that works. Yep, it works. After that, we got a message right now, a warning. Balance. I'm a student. Here it is, what Kirsten says. But I want you just to forget about the warning message for a second, and just concentrate on the method which we just did in the student class. What we did actually is, we didn't replace, but we hid the method from the human. As you can see, if we do that, if we use in the student method, which inherits from human, if we define another method with the very same signature, what happens is our method actually in the class student hides the underneath method which is in the base method. And what the compiler tries to tell me is this method, student introduce yourself, hides inherited member introduce yourself. Use the new keyword if hiding was intended. Okay, I just wanted to hide, so I'm gonna use the new keyword. In other words, just to make it clear, in C#, they use the keyword, the modifier new, just to tell the compiler that what we want right now is just to hide the method from the base class. And this is exactly what we want. The human method still exists in the human class, and we're just hiding it by defining the very same method, this method with the same signature, in the student class, which inherits from human. Okay, but what if we want to call introduce yourself from the base method and from the base class? All we have to do is just use the keyword base, and this is in power also for the methods, for other methods which are hidden. This is how you access the elements of the base class. So I'm gonna say base introduce yourself. As you can see, you can access all the methods, all the elements from the base class with the base keyword. So I'm gonna call the method from the base class to do the part of the job. So I'm gonna introduce Kirsten, our student, as a normal human being, and after that I'm gonna add the extra information which I wanna get for Kirsten, for the student. As you can see, we have achieved a perfect code reuse because we're using part of the code from the base class, and we just augment, we just add whatever it's necessary, specific for our program. So right now the student is gonna introduce himself in two rows. In the first row is gonna say is gonna introduce himself as a human being, which we want, and after that is gonna augment. The expression is gonna say my faculty number is such and such. Okay, let's start it and see that. Okay, here we go. My name is Kirsten. I'm 25 years old, my balance, blah blah, and this is the second line which comes from the introduce yourself method defined in the student. Okay, I just wanted to show you how can you access, I just wanted to introduce first the hiding of the methods and show you how to access the methods which have been hidden from the base class. Okay, let's assume that we wanna do something like that. I just wanna show you something else right now. Okay, this guy doesn't wanna call the method from the base class right now. Let's say that we wanna introduce the student by saying the name property, by saying the age property which comes from the base class, and also we want to add the faculty number, and we are gonna do that directly in the introduce yourself defined in the student. Okay, I'm a student. I'm gonna say my name is, after that I'm gonna use the property from the human class, which is the base class. My name is 0, just to show the access modifiers. My age is, I'm gonna say the age, I'm gonna put the placeholder for the age, and after that I'm gonna use the faculty number. So name, age. Notice something. Right now the properties name and age are declared as public, so anybody can access them, as well as the class student, because it inherits from human. Let's see how that works, and after that I'll show you something else. Okay, start the program, and we will see that right now Kirsten is using the new method. I'm a student, my name is Kirsten, my age is 25, my faculty number is 234, whatever. Okay, so now what if we don't want to use the properties name and age? What if we want to use the fields, which keep the values of the properties? As you can see, we cannot access them, and we cannot access them because they're declared to be private. In order to allow the classes which inherit from a given class to access elements, we have to declare they are protected. So far we have used two different access modifiers, private and public. So if we want to follow the best practices of the object-oriented programming, and we don't want to give direct access to our fields from outside world, but we still want to give access to the fields to the classes which will inherit from our base class, then we have to declare these fields protected. So these fields are accessible from the files, from the classes which will inherit our class, but they're not accessible from outside world. This way our program will continue working very well. Start, and voila, it still works properly. I'm a student, my name is Kirsten, my age is 25. So I show it to you how to access fields from the base class. We just have to change the access modifier to protected, and if we want to, of course, continue keeping the best practices, not to expose our fields which keep the values of the properties. Okay, now let me take a look my mind map and access modifiers, class object. Okay, I have to reveal another secret. Now let me tell you the truth. If you look at here, if you put for example student1 and you look at the methods, you will see that there are some methods which are coming from nowhere. Get hashcode, get type, toString, equals. Where these methods are coming from? The reality is different. The reality is that even if we don't want, we always inherit from one class which is called object. This is what the compiler actually does. In the reality, this is how the situation looks. I'm gonna draw again. It's not a UML diagram, it's something like a popular diagram. So this is the class object. It's called like that, object. So each class which we create, in fact, inherits the object class. I'm talking the classes which doesn't inherit from any other classes. So even if you don't explicitly inherit from some class, then what happens is the compiler actually implicitly adds inheritance. It makes our class to inherit the class called object. And this is our, I want this red, this is our human. And after that we have student and athlete. This is the real situation. In fact, all our classes which don't inherit from our other classes, they inherit a system class called object. That's why we always by default have these extra methods which are inherited from our object class. One of them, for example, is toString. Okay, so this is, we said this is student, and this is athlete. This is athlete. This is the real situation. In other words, here what happens is this object. So there is always inheritance. Always inheritance. It's implicit. Even if we don't do that, the compiler would do for us. Okay, this is the real situation. Now I wanna introduce two other terms, which are upcasting and downcasting. So I'm just tempted to show you something, and after that I will try by one example, by one use case, to make it clear. Can we actually assign an object from a class student to a variable which is from class human? We can, and what happens is upcasting. It's called upcasting. Right now, if we call student one, we'll see that the student actually lost all his specific properties typical for students, and all we have are the properties and the behavior of the ordinary human being. This is called upcasting, and I'm going to show you this by one example, by one use case. So right now our student will introduce himself not using this method, introduce yourself, I'm a student, blah 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 blah. It's gonna use the hidden method from the human class. It's gonna use this one. It's gonna say my name is blah 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 blah. Okay, let's see that. And because many students ask themselves, why did we inherit from a human and after that we did upcasting, I'm gonna use one use case. My name is Kirsten, I'm 25 years old. So in other words, my poor student, he forgot that he is a student. He behaves exactly like an ordinary human being. He is not a student anymore. He doesn't have the properties of the student, he doesn't have the behavior of the student. This is called upcasting. Okay, so let's stick with one funny example just to try to understand why we're doing that. Okay, what I want right now is, I don't want to call this ordinary humans from my domain. Let's pretend that we are the king of this, we're the kings of this domain, and we don't want to call directly these human beings ordinary peasants and ask them to introduce themselves. Let's delegate this to an executor. Let's say this is our guy who is our right hand guy, our closest guy, and we just turn to him and say, make him speak. This guy will hold one human being, and because he is the perfect, how to say that, he knows the behavior of the human beings, he knows how to make one ordinary human being to speak. Okay, so let's define the class for this guy, executor. We'll call this guy executor. So we're not gonna work directly with our poor people. We are gonna delegate this communication to one guy, executor, and this guy knows the behavior of the human beings. He knows how to torture them and make them confess, and he will make them speak. It's really a funny example. I just try to make something which is colorful and probably will remember it better. Class, and I will call this executor. executor. Okay, so this guy needs a field where to hold one human being, private human person. After that, let's allow him to set and get this poor human being. We'll say public human person, and after that we'll say get return person, and we'll have one setter, of course, where we can replace the guy who our executor needs to torture. Okay, set person equals value person. This person, of course, with a capital letter, and everything should be okay. We want to give the executor the person immediately when we construct one of executors. So I will say public, it's not returning anything, executor, I will say human person, and we are not gonna call any base constructor. We're gonna call, oops, of course this class inherits from object. The real situation is here, it's like that, object, but we don't have to explicitly declare that. So public executor, this person equals person, and after that the most important method, make him speak. Public void, we'll say make him or she make him speak. After that we'll say console write line, just to scare the poor victim. We'll say I am the executor confessed, and our poor human being will say person, because the executor knows secretly about this secret method, introduce yourself. He knows perfectly how to make the person speak. He knows about this API. He's gonna use this knowledge, introduce yourself, and after that the executor will say ha ha ha, because he has been able to make our person speak. Okay, I hope you imagine the situation. Okay, let's see now if our executor can make somebody speak. Okay, we'll instantiate one object of class executor. We'll call this exec1 new executor, and we're gonna give him one poor person, person1. This is what's gonna happen in the dungeon right now, where the executor actually makes our victims speak. Start, and what is that now? My Christian, okay, make him speak. A student, my name is Christian, my blah 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 blah. Okay, wait a second. I created the executor, but of course I didn't call his method exec1 make him speak. Yeah, I made a syntax error here. I mean, I will use here make him speak with a small letter, and I'm gonna correct this, make him speak. Okay, now everything should work fine. Start, and let's see what happens. Here we go. I am the executor, confessed. And our poor victim just introduced himself as a human being. My name is Toyan, I'm 50 years old, and my balance, in other words, he says everything what he knows about himself. Okay, as you can see, our poor person introduces himself as a human being, as an ordinary human being, because the executor looks all the victims as ordinary human beings. He perfectly knows how to deal only with human beings. Okay, the big question right now is, can we make our executor work with students? Will our executor take a student, and what is going to happen? Student. Let's see first. Actually, it's not necessary. I'm going to show you that. As you can see here, the student introduces himself here without the executor, and after that in the dungeon, because we have given the student to one brutal executor, which is gonna make him speak. And let's see what the student will say about himself, how he's gonna introduce himself. Is he gonna introduce himself as a human being or as a student? Okay, as I said, I will repeat again, our executor knows how to deal only with human beings. Start, and here we go. Kirsten introduces himself when we ask him politely, outside of the executor, as a student. He says, I'm a student. My name is Kirsten. My age is 25. My faculty number is 2345. But when we give Kirsten to the executor, he introduces himself as a human being. My name is Kirsten. I'm 25 years old, and my balance is 14. My nationality, blah blah. As you can see, Kirsten doesn't remember anymore the fact that he is a student. He have been upcasted to a human, so he behaves as a human being, as an ordinary human being. This is very important, and this happens because we just hide the human behavior into our student. So both behaviors, if I can say that, still exist. The method, the base method, introduce yourself in a human, still exists, is not replaced in this situation. Can we make so that our student, even though it looks like an ordinary human being, introduces himself as a student? Can we, in other words, replace the method introduce yourself from the human class? Yeah, it turns out we can do that by using the keyword override and changing the method introduce yourself in the base class to virtual. If we do that, now Kirsten is gonna forget completely about the fact that he has been a human being. He's gonna introduce himself as a student. This is something magical. The executor thinks that he works only with human beings. He sees all the variables he gets, all the objects he gets. He sees them as a human, but they are polymorphing, changing their behavior depending on the type of the objects we are sending to the executor. Okay, I just went ahead myself. I just introduced it a little bit from the polymorphism, but I just wanted to show this, how is achieved when we inherit actually from a base class. So let's start the program and confirm that right now Kirsten doesn't remember anymore the fact that he has been a human, and even when tortured in the dungeon by the executor, introduces himself as a student. This is very, very important. As you can see right now, even though our executor works with Kirsten as a human being, he still introduces himself as a student. Okay, the method from the base class has been totally replaced, and the method from the student class has been used instead. So I'm a student, my name is Kirsten. So even upcasted, our object from type class type student has the behavior, in this case, of the student. It introduces himself as a student. This is very, very important. Okay, what's gonna happen if we don't use virtual here in human? Let's try and see. Probably the compiler will give us an error. Let's try and see what happens. Yeah, it's error. So if we use override in the class which inherits, we have to use virtual here. Oops. Okay, I'm gonna type it. Virtual is gonna be easier like that. So right now it's gonna work, and this is very important thing. This allows us actually to build hierarchy of classes and use generalization. In other words, what we told the executor is treat them as a human beings, and they change their behavior. The objects inside of the executor change their behavior according to their real type. This is very, very powerful technique. It's like a magic. Okay, if we just want to hide the class from the base class, the method from the base class, all we have to do is just use the keyword. Instead of override, we have to use new. Okay, let me try that. Now, as you can see, as a result of the upcasting, the hidden method shows up. My name is Kirsten. This is very important. So it depends on what do we try to achieve. Usually we try to overwrite, because this gives us a magical power in our hands. We can work with entire hierarchy of classes by using the class which stays in the root. In other words, we tell actually our executor to work with humans, which lies in the root of our hierarchy, and after that we can send different objects from different classes which inherit human, and they will be treated the same way. In other words, we don't have to write executor specially for students, or specially for students and specially for athletes. We write the code only once for the human. After that we create this hierarchy, and our executor can work with all objects from this hierarchy. Let me take a look at the mind map and show you something extra. This is called generalization in the world of the UML. This is UML means comes from Unified Modeling Language. This is how the classes are represented in the class diagrams. This is the name of the class, those are the properties, and in the third box we represent the methods. And such a relationship between the classes is called generalization, and it's represented by this triangle. In other words, we could put here human, and all child classes which inherit here. This we will put student in our case, and here probably athlete. As I said, this relationship is called generalization. We generalized the term human, as you can see, and we are working with this generalized term, with this generalized class, which is inherited by other classes. There is another relationship which is called association, which we are not going to look at right now. And this relationship association also has two subtypes, if I can call them like that. Accommodation, no accommodation. It's composition, association, many to many, aggregation, and composition. Here it is. With plus, actually, we show that a given method or a given property is available, is publicly available. With minus, we indicate the private, and protected is with this pound sign. The relationship association could be many to many by attribute, one to many, one to one, and as I said, the association could be aggregation and composition. In the famous book Gang of Four, Eric Gamma and the rest of the guys, design patterns, elements of the reusable software, actually we have to favor composition and use composition if it's possible, but not generalization, not inheritance. But we will talk about that later. Thank you for watching this. Hopefully it was useful for you, and see you the next time.